Think about your system right now. You probably have a browser open, maybe a code editor, music player, maybe even a few background apps. All of these are running at the same time, and all of them need memory. Now here's the real problem. If you add up the memory needed by all these apps, it's often more than your actual RAM. So how is your system still working smoothly? Why doesn't it just crash? And that's not the only issue. Even inside RAM, things aren't neat. In older systems, only one program ran at a time, so its data sat nicely in memory. Simple. But today, multiple programs run together. Each one has its own code, data, heap, stack, and all of this gets placed somewhere in memory, not in one block. Sometimes split, sometimes scattered. So the real state of memory is messy, fragmented, and hard to manage. Now, imagine you're a programmer dealing with this directly. You'd need to know where your program is stored, which parts are split, and how memory is shared with others. That would be extremely difficult. So what does the operating system do? It hides all of this complexity. Instead, it gives each program a clean, simple view, almost like an illusion. This illusion is called virtual memory. So from the program's point of view, it just feels like, I have my own memory. Starting from 0, going all the way up, nice and continuous. This is what we call the virtual address space. Inside this view, memory looks well structured. Your program code is there, the heap handles dynamic memory, and the stack takes care of function calls. And as the program runs, heap and stack can grow. But here's the key idea. This view is not real. In reality, the program's memory is scattered across different parts of RAM. But the program doesn't know that. It only sees the clean virtual view. And this gives us 3 big advantages. First, simplicity. You don't have to deal with messy memory details. Second, efficiency. The OS can manage memory much better. And third, protection. One program cannot access another program's memory. So in simple terms, virtual memory is an abstraction. It gives every program a clean and simple view, even though the real memory is complex and shared. But now comes the interesting question. If this is just an illusion, how does the system actually make it work? How does the CPU convert a virtual address into a real physical address? That's exactly what we'll understand in the next video. So consider subscribing, and I'll see you in the next one.